So one of the reactions you're going to need for the problem set that you do on Monday is the Mannich reaction. And this is a reaction of enols that enables you to make beta amino ketones. So we've done lots of enolate reactions to make different carbon-carbon bonds. In this reaction, we're going to use iminium ion electrophiles. Right? So this is going to enable us to make a carbon-nitrogen bond so that instead of making beta amino alcohols, 1,3-dicarbonyls, we're going to make beta amino ketones. So I'll show you a reaction and then we'll go through the mechanism. So if we take acetone plus formaldehyde plus dimethylamine, react that in the presence of HCl, that will do a Mannich reaction to generate a beta amino ketone. So alpha beta, that's our beta amino ketone. Right? So this is just a generic Mannich reaction. Right? Now, if we think about the mechanism for this reaction, right, the key thing with the first step in the reaction is to make the iminium ion electrophile. Right? So we're going to focus on reaction of formaldehyde with our secondary amine. Right? And when you're thinking about the Mannich reaction, we're always going to combine a ketone, formaldehyde, and a secondary amine. It'll always have formaldehyde. The two variables will be the ketone and the secondary amine. Right? So let's react these two components first, the formaldehyde and the secondary amine. They're the things that will react the fastest, and they'll give us the iminium ion electrophile. So, as usual, when we have a carbonyl and acid, let's first protonate carbonyl. Right, and once we've activated formaldehyde, we can add secondary amine. Right, and then we can just do our standard carbonyl chemistry. Alright, so there's our tetrahedral intermediate. We can do a proton transfer. Now we're set for water to leave. And we've generated our iminium ion electrophile. Right? And as we set up here, our nucleophile is going to be an enol, so let's generate our enol, and then we can see how the enol reacts with the iminium ion to give us the beta amino ketone. Right? So if we start with acetone, again, we can react that carbonyl with HCl as well. And then we can just do the reverse of our standard tautomerization reaction, generate an enol. And now we're set to have the enol react with the iminium ion. And all we have to do to get the final product is just do a proton transfer. We can use Cl- to regenerate the HCl that we used in the beginning. So that's the Mannich reaction mechanism. Again, standard chemistry that we've done before, but the key is that we have the enol nucleophile reacting with the iminium ion electrophile. So let's do a synthesis problem involving this just to illustrate how you might use this, and then you should be in good shape to work on the daily problems for Monday. So here's a problem just to illustrate how we might use the Mannich reaction in synthesis. So here's a target that we want to make, and we want to synthesize it from 8 carbons or fewer. And if we look at this compound, again, thinking about our retrons, so if we look at this, this is a beta amino ketone, and that's the Mannich retron. And when we think about what happened in the Mannich reaction, we use the alpha carbon as the enol. Right, so that's going to be the enol. The beta carbon came from formaldehyde. And then the amine piece was the secondary amine. So if we think about the bonds that we're going to break, it'll be those 2 bonds, so that we have the enol portion on the left, formaldehyde in the middle, secondary amine on the right. And going backwards, there's the enol plus formaldehyde plus the secondary amine. All right, so let's look at what this synthesis will look like in the forward direction. We'll start with acetophenone. React that with HCl, formaldehyde, and the secondary amine. And when thinking about the mechanism, we'll end up with our enol nucleophile plus the iminium ion electrophile. And then after proton transfer, we'll generate our target. Okay, so that's an example of using the Mannich reaction in synthesis. And again, for the daily problems that you have due on Monday, there's a beautiful Mannich reaction problem that illustrates the synthesis of a natural product called tropinone.